Welcome back to the Decarb Connect podcast. My name is Alex Cameron. I'm the founder of Decarb Connect. And today I have finally pinned down someone that I've been trying to have a podcast with for, well, you can remind me, Ben, but probably 6 months or something like that. Benjamin Tincq, who is the founding partner of Marble Studios, who help, well, we'll learn more about what they do, but they're kind of the headline for Marble is that they help founders create companies that can go on to tackle some of the toughest climate problems. So they sit right at the earliest stage of innovation to scale. And the goal for today is to learn a little bit more about Marble, of course, but to look specifically at how industrials are engaging with early stage companies to help scale up negative emissions technology. So yeah, interesting to hear about Marble, but an interesting topic to hit on. So welcome to the podcast, Ben.
Thank you, Alex. It's a pleasure to be on the pod.
So as a kickoff, I'm going to ask you the question I ask everybody, which is, tell us a bit about what has brought you to this point in time. And really, I'm interested in as much about your personal drivers as I am professionally, but give us that feel for how have you arrived at this point in time, and then we'll talk more.
Yes, happy to. So I have an engineering background. Initially, I come from telecommunications engineering. And then after I left university, I worked in consulting for a few years in tech consulting. And almost like by chance, one of the first assignments I worked on was on climate and clean tech. So that was about the time of the Copenhagen Climate Conference, so the COP50 in 2009. And that was basically my first exposure to climate and why it was such a pressing problem and why there was a need to develop new solutions. So I was working on looking at the clean tech sector in particular. Then I spent a few years in that company, worked on a different subjects as well. Then I left to found and lead a nonprofit that was focusing on technology for social innovation and sustainability. And that led me to run a small climate solutions incubator the year of the COP21, so the Paris, that led to the Paris agreements. And then basically I realized back then that I really need to expand a bit my knowledge and network to better understand the full scope of climate solution. And I got very fascinated about what's called deep tech entrepreneurship. So that's basically when you create new companies that are based on new scientific discoveries or like really tough technologies, not simply like software and mobile applications or this kind of thing. And I thought that this could really be a high leverage for climate solutions and sustainability. So I started to get involved with a few deep tech networks like Hello Tomorrow, which is one of the biggest network and conference focused on deep tech entrepreneurship. I founded a new company called Good Tech Lab back then, which was a clean tech market research firm. So we were working with different customers, so industrial firms and others who were interested to understand the latest trends in clean tech, including carbon removal, hydrogen, and others. And we'll talk a bit about that later. And on the side, I got involved with a few startups myself. So I put a small investment ticket in a biotech company and a fusion power company, and worked a bit with the founders. And at that time, I realized, okay, I really would like to either launch a startup myself and run that company, and that was my conclusion, that actually I couldn't really find like the one topic I would be ready to spend the next 10 years of my life working on. And I realized I wanted to work on a breadth of topic all around climate solutions. So I wanted to found what's called a venture studio, or a program to help different founders and entrepreneurs to launch their companies. Started to look for a partner, and I found my co-founder, Johnny, who's a Brit who's been living in Paris for 3 years now, and he used to run another program called Entrepreneur First in Paris, and then he wanted to move on to his next journey in climate. We met at the right time, so we teamed up, raised a small fund, and that became Marble. And that's where we are. And in parallel, I got involved with I have another hat, a non-profit hat. I'm on the board of a non-profit called Carbon Gap, which is a European climate NGO, which focus on European policy for carbon dioxide removal, so removing CO2 from the atmosphere. And yeah, that's the story.
So from that Copenhagen kickoff to now, how many years is that in this kind of early stage of deep tech development, would you say?
Yeah, so it was a non-linear path, but let's say it's been 12 years, I think, something like that.
Well, definitely an interesting background to bring to Marble. So I gave this probably slightly clunky introduction to what Marble does, but I remembered from our onboarding call, I really love this phrase you use about it's all about finding the right people to tackle the toughest problems, and it's as much about the people as it is about the right problem, I guess, rather than some kind of particular technology that someone's then trying to do something with. But maybe you can spec that out a little for the listeners. So tell us a little about Marble, but yeah, what is that issue that you're created to solve?
Absolutely. So Marble is a venture studio focused on climate tech. And so a venture studio, you can think of it as a company that creates companies. So it works a bit the same as an investment fund. The main difference is we invest only in new companies that we create from scratch, focusing exclusively on what we call hard climate problems. So we think there's basically a lot of available technologies that are ready to scale and that are scaling to tackle about half of the emissions that need to be abated, and we need to deploy them very fast. But in parallel, there's a need to tackle these hard to abate emissions, so including from hard to abate industries, but also being able to produce the negative emissions, which are planned in the climate modeling of the IPCC. And we're based in Europe, and we think Europe can play a much bigger role in these hard climate problems that it does today. Europe has been very good at scaling available solutions, but I think with the incredible talent and science and the corporate customers and the capital that's available in Europe, we could play a much bigger role in basically incubating and developing and scaling the next generation of climate solutions for these hard to abate problems. So we focus on these, and we think that we try to bring something that's complementary to tech transfer. Tech transfer takes usually IP that comes from a university and then commercialize it and build a company around it. We try to take basically a step back on specific problems. So for instance, creating low carbon fuels for heavy transportation or developing a certain kind of carbon removal technology. And then we partner with scientists, engineers, operators who are like deep technical specialists on this area and who have ideas but not yet have a team. They don't yet have a necessarily a precise idea of what they want to do, but together we iterate around that problem space. We come with like predefined problem statements and we explore to find what would be the best technical solution to that particular challenge, and we build that company together with them and bring together the rest of the team, their co-founders, and we basically become the first investor in the company we create together.
Okay, and then I remember you were telling me that I think that there are four kind of main areas that you're looking at. So you know CO2 removal, obviously, reuse, and then what are the other two areas that you're kind of particularly engaged around?
Yeah, so in terms of what we focus on, we have like three, so mainly two plus a third main sector. One is really the decarbonization of hard to abate industries. That's a big bucket. The other big bucket is carbon dioxide removal, CDR, so removing CO2 from the atmosphere to sequester it for long durations and potentially also to reuse it to make low carbon products. And then a third small bucket is adaptation to the effects of climate change. And then within that landscape, we have, as you rightly pointed, we have 4 projects in our pipe today. I mean, I can talk briefly about them. So one is a direct air capture project, and I can talk more in detail about negative emissions and direct air capture. Two are making basically basic chemical feedstocks, either as fuel or to decarbonize the chemicals industry. So one is working on methanol, the other on ammonia. And then we have a project which is a bit different, which aims to basically help to do desert farming, so turning basically being able to grow food in coastal deserts by misting seawater in the atmosphere to lower the temperature locally and be able to create new arable land and potentially to sequester carbon also in these areas.
Wow, so that's already some quite impressive and quite distinct projects that you're engaged with. So well, I know we're going to come back to at least one of those, the direct air capture as more of an example. But before we do, I said at the beginning that the kind of, the purpose, I guess, or the theme that we were going to focus on was engaging industrials as a partner in scaling negative emissions tech. So why don't we start with the industrials and your perspective on that? So when you sort of bring this discussion of scaling negative emissions tech to them, what's the kind of typical response? How kind of clued up and kind of engaged already in that concept are the kind of the majority of the companies that you might talk to? And just give us a sense on like, where are you seeing that industrial focus? And yeah, we'll go from there.
Absolutely. So I think it's first maybe for listeners who are joining on the podcast for the first time, maybe. So these industries, like, what are they? So the way I see them is that we're basically talking, when we talk about how to abate industries or how to abate industrial sectors, we're talking about, I think, in most part for industries which are hard to electrify, because we know like the electrification and clean electricity is going to solve a lot of climate challenges. But for the industries where it's not easy to electrify what's causing the emissions, it's much harder. So that includes industries focusing on, for instance, cement, steel, chemicals, glass, ammonia, aluminum, all of those, even though aluminum is a little easier to electrify than the others, but still not fully easy. Then you have all the heavy transportation sector, so maritime transports, planes, trucks, rail. And then you have, I would say, probably maybe like things like mining and construction, which would be like two other big buckets. And so basically, when you want to decarbonize these industries, you need either to be able to deliver a low carbon, carbon neutral energy source. So, and when it's not power, we're mostly talking about high temperature heat to decarbonize industrial processes, and also energy dense molecules, so fuels typically in particular for transports. You want to also to have these clean molecules as feedstocks for industrial processes. So for instance, like compounds like methanol or ethylene, which are like the building blocks of many products we use every day. And in some cases, you want to decarbonize a fundamental process, like how we make cement. The way we've been making cement forever has been basically taking limestone, which is like CaCO3, so calcium carbonates, and when you break it down, you get a reactive CaO, calcium oxide, and you get carbon dioxide. It's like the chemical equation. So basically, there's a lot of interest in reinventing this process to get rid of the CO2 from the process. So basically, there's a lot of options and a lot of technologies, pathways to decarbonize these industries. But even if we do that, and even if we go as fast as we can, there's likely going to be a remaining bucket of emissions that it will be really, really difficult to abate and to decarbonize. And for those, we'll need to compensate them. We'll need negative emissions to reach the famous net zero, or even potentially net negative in the future. And so the IPCC models tell us that on aggregates, on a global scale, we'll need about between 5 and 15 billion of tons of negative emissions by mid-century, which is like really, really massive. And these companies these corporates, these industrial companies that have net zero plans will need to contribute basically to that goal, because to balance their net zero plans, they'll need negative emissions to do that. The thing is, like today, there is nowhere near the supply that is needed to deliver enough negative emissions for everyone. So we know that there are a lot of available solutions, particularly in the nature-based type of solutions like reforestation and soils and so on. But for the more durable, the more permanent, the more additional type of negative emissions, direct air capture, mineralization, and many other, we're still at the very, very early days, and we need to scale up the supply. So there's a big need for industrials to get involved, for instance, as early customers, to help down cost these technologies with more and more deployments, like it happened with solar power, for instance, or with lithium-ion batteries. It's by deploying them that the costs started to fall. But also these industrials can get involved, I think, in different ways to help to deploy them, by providing the energy supply, by providing all the industrial deployment expertise, helping with siting, helping with infrastructure development, in some cases developing new materials that are going to help to these technologies even better, and so on.
Yeah, and so we hear a lot from members in our network, people we meet at events, and the kind of the client base that we come into contact are very much those types of companies that you described, cement, steel, etc. And many of them are involved in demonstrations and pilots, but there's still, a kind of, I guess there's still the ongoing question of how many of these can we do at once, and what's the benefit in being a first mover? That's still a question you hear from some companies. I'm wondering, like, how do you address that? What's the conversation that you have that would get them involved with such early stage technologies and technologists that you're representing?
So I think there's like at least two main reasons why, potentially more. I think one is some of these industrial companies might have an interest in either like launching a subsidiary or basically expanding their activity into CDR and negative emissions, because we're basically talking about building an industry the size of the oil and gas and mining industry, but working in reverse, meaning it's not an extractive industry anymore. It's going to be an injective industry. The goal will be like to pull so much CO2 from the atmosphere and re-inject it in the underground and in the oceans and everywhere we can sequester them. So there's going to be a huge opportunity to help this industry grow. And I think some large companies might be interested in being part of that new industry. The second is that since the supply of CDR is very constrained today and is likely to remain very constrained for quite a while, I think for the large companies that want to be among the first to deliver on their climate goals and to be among the first to reach their net zero ambitions, they are going to be, it's going to be important for them to be able to secure the supply of high quality permanent CDR. And I think by building these relationships with the pioneers, with the technology developers, I think they will increase their chance of being among the first that will be able to purchase these CDR credits from these companies.
Okay, all good reasons. Excellent. We can end the podcast right there. No more problems. Super easy to solve. All right, so that's a kind of a fair, I think that's a good kind of foundation for then the next phase of our conversation. We've talked about the industrials, we've talked about the specific challenges of why they are so hard to abate. We've kind of had a bit of an overview of some of these negative emissions technologies, but why, I don't know if you want to pick one of them, maybe it's this project around direct air capture, but what's the challenge in getting the right solutions to scale? Because I think this is one of the interesting things that sometimes from outside of the market looking in, I'm not sure there's always a good understanding of why does it take so long to get a technology not just working at its scale, but actually rolled out. But so maybe you can sort of paint that picture. And maybe it's around that direct air capture project that you're talking about too.
Absolutely, happy to. I think I'll answer in two parts. First, maybe giving a quick overview of like what's the different types of solutions we're talking about, and second, maybe picking one and explaining why it's difficult and what we can do to make it faster and better. So, so as I mentioned, there's some negative emissions solutions that many people are familiar with, including the nature-based solutions, so reforestation, soil carbon sequestration, biochar maybe, and so on. So historically, many have divided conceptually CDR into nature-based solutions and engineered solutions, which is somewhat helpful. I think another way to look at it would be processes that use chemistry and processes that use photosynthesis to capture the CO2. And yet another way to look at it would be solutions where the carbon is sequestered in plants, in minerals, which can be rocks or dissolved bicarbonates, for instance, or in CO2 that is sequestered underground, like in CCS, like the same type of storage, or maybe like long-lived products, like concrete, for instance, would be one example. And then, so the type of approach we focus on, we try to focus on a CDR approach, which have a high chance of leading to really long duration, durable, close to permanent CO2 sequestration, and that are really additional compared to what's already happening. So direct air capture is one, and I'll get back to it, but the basic principle is that you're trying to use a material, either liquid or solid, that acts as like a sponge that sticks to the CO2, and then you're using some form of energy supply to be able to re-separate the CO2 from the sponge, and you get back the CO2 and you sequester it underground in many different forms. Then another approach we focus on, and when we're actively sourcing first founders, is carbon mineralization. So it's different processes where you basically expose CO2 to minerals in order to create rocks. So you can do that in many forms. You can do that on land. You can do that in situ, ex situ. So the main interest of carbon mineralization is that it's really energy efficient. Direct air capture is like really energy intensive. Carbon mineralization doesn't require any external energy inputs. It relies on very abundant resources, but it's very slow. So there's a lot of innovation areas on how to increase the speed at which it's happening. Then we're also very interested in ocean carbon removal. So there was a big report last year from the National Academies of Science, the US National Academies of Science, on the potential of using marine geochemistry or marine biomass to capture and sequester carbon. So we are very interested in that as well. And then we're also very interested in clever ways to use biomass processing and biotechnology to capture and sequester carbon. So that's a bit like the landscape of what we think is like really interesting in that space. And then you asked the question why it's very difficult to build this. So direct air capture, basically you're almost like you're fighting against the laws of thermodynamics, because CO2 is extremely dilute. It's 400 particles per million in the atmosphere. So you need to grab like just the tiny molecules of CO2 from a mixture where you have oxygen and nitrogen. You need then to supply energy to re-separate the CO2 from the solvent and the sorbents. And you need to do that at a very, very large scale. So there's a lot of air you need to flow in the system in order to separate it. And you need to bring a lot of energy to separate the CO2 from the material. And so if you want to develop a direct air capture system that is highly scalable, I think one of the most important things you need to consider is to make sure that at scale, it's important that it will cost, that will be cheap enough basically to work with carbon markets in the future. But I think even more importantly, I think everyone today focuses on, okay, 100, 150 per ton, which is a target. But I think something that's going to be even more important, in my opinion, will be the energy cost per ton. Because when we see like, I mean, there's a lot of great like companies out there and we really fully support them. But we look at sometimes like the energy requirements per ton or per gigaton that some of these processes will need at scale. It's hard to understand how basically maybe like one process or one company for 1 gigaton might require, let's say, like a third of the US electricity supply only for 1 gigaton, you know. And so it's difficult to imagine, with so many competing use for clean electricity and clean heat and clean power, how we're going to be able to scale that in time. So we need to go back to the drawing board and design like the most energy efficient direct air capture system possible, working on techno-economic analysis from the very beginning. And then once we found something like that, we need to help deploy them fast, and basically like solar and lithium-ion batteries to count on learning curves and deployment incentives to help scale them. So sorry, that was a pretty long answer, but
no, it was a good answer though, and I think it is interesting, because whilst there are people who are listening who are no doubt, you know, experts in that field, I think honestly for most people, even those people who are already engaged in industrial decarbonisation, this is the outer reaches of anything familiar, isn't it? So we'll talk about in a moment. We'll talk about what's it going to take to get to that cost-effective stage deployment. But just to paint the picture again, like it's always fun on a podcast, which is audio based, to try and paint a picture of what this is going to look like. But some of us will have seen in newspapers like these examples of some direct air capture tech, and it kind of looks like, you know, a massive stack of air conditioning units or something like that. Yeah. Just paint a picture, like, you know, in 10 years time, 20 years time, what is it going to be like? Is this the kind of thing that would turn into a direct air capture farm, or is it going to be on specific sites? Like, how do you imagine it being deployed, just as a final part of this picture painting?
Absolutely, no, that's a very good question. And I think, I mean, the big flexibility you have with direct air capture compared to, let's say, point source CCS. And again, the two serve very different needs. Is that you have you can have a little more flexibility on where you want to deploy it, but the main geographical constraints you have is, I mean, you have two main geographical constraints. The first one is that you need to be close as possible to a very to a good storage site. So either it's like classic geological storage, like supercritical CO2, which is pumped underground, or you are close to a site where you can mineralize the CO2, meaning turning the CO2 into rock, usually by mixing it with water and pumping it underground in like basalt formations. So that's what's happening, for instance, in Iceland, the partnership between Climeworks and Carbfix, which have been really at the forefront of this process. It's happening also in Oman, also with a 4401, which mineralize CO2 into rock. Is going to happen in many different areas in the future. And I think we are going to have these direct air capture hubs localized where you have this storage site, but also where you have a lot of low carbon energy, whether it's electricity or heat, depending on what you want to or how the process works. So if it's heat, I'm really bullish on geothermal. I think geothermal is going to play probably a big role in direct air capture in the future, but also where you can have like really cheap, abundant solar and wind power. I think nuclear is going to play a role both for electricity and heat as well. So you'll basically probably have these big hubs of direct air capture happening in these favorable regions. It's important also to note that certain direct air capture process work better in certain latitudes or in certain weather conditions, depending on the level of humidity, for instance, or things like that. So you're going to have these parameters which are going to play a role as well.
Okay, all right. So useful. Let's then step into this thing of what it takes to get this to a cost-effective stage of deployment. And I guess this also feeds into then the work that you are doing within Marble to help new technologies, new founders and companies to scale, not just quickly, but cost effectively. So talk us through that. What's it going to take?
So I think it's basically for any CDR solution, the target that many companies and projects take is, can you get to about $100 per ton approximately? I don't know whether it's going to make a huge difference in the long run, whether it's going to be, let's say, 100, 120, 150, or 90. I think this ballpark is probably like a good target, because then you will be able to leverage not only the voluntary carbon markets, which is what most of these companies have been relying on. So when you have companies like Stripe and Microsoft and Shopify, I know like Frontier Climate purchasing these negative emissions credits, it's basically voluntary markets. But then when you start to reach that price point, you'll be able to leverage the compliance markets, meaning potentially in the future the ETS and other carbon markets. So I hope that's going to happen in the future. So that's the right price point to focus on. But the second big constraint, specifically for direct air capture, would be like, how can you make it like very energy efficient, so that you won't be constrained by the lack of energy infrastructure to be able to power these systems. Then for other approaches like carbon mineralization, for instance, the energy supply is not so much the issue. It's more like, can you engineer a system where you would drastically accelerate the speed at which the reaction occurs. So I think basically the way we try to approach this is to really look at what's technically possible, what are like the different technological pathways to make a system work, and then try from the very beginning, even before you build anything, like to make a very detailed techno-economic analysis, meaning like what are the different parameters in terms of energy supply, the cost of materials, and what does it happen when you buy them at scale, and how does the price of these materials fluctuates, and how does the whole system come together, and can you reuse waste energy and all of that. And you try to really stress test this kind of model to see whether it works, and then you need to have a clean technical roadmap for how you tackle all these challenges. And then the thing is, like, usually your first system is going to be quite expensive. And when you look at the early stage CDR companies, so Stripe, the payment company that purchases a lot of emissions, they did something really good, which is they ask all these companies that apply to document their process and their cost per ton. And you can really see, like, for all of these companies, you have usually like a very expensive price per ton at the very beginning. So it goes from like a couple hundreds to $2,000 or $3,000 per ton sometimes. But this is like only like the first pilot unit or proof of concept unit. And the thing is that then you have a lot of technical drivers to pull when you go from unit 0.1 to unit 0.2 and so on. And you can get from maybe like 2,000 to 500 to maybe like 400 and so on. And I think even if it's expensive today, the question is like, do you have all the right levers to pull to go from this very expensive price today to this 100-ish price per ton in the next decade, basically. And that's more or less also the criteria that the X Prize carbon removal took as well. It's like, can you get to this price per ton in the next 10 years?
So let me just sort of chuck in a slightly, well, it's the same, it's asking about the same thing, but sometimes you will read or you hear from climate activists quite rightly asking, what does it take to get this done faster? So if we want to apply COVID thinking to this, where we get vaccines done in months, not years or decades, what is it that could happen to enable that? So in the COVID vaccine example, obviously the big change, which was part of what riled some people up, was the changes to that regulatory sign-off. So that's a slightly different thing. I understand that, but what would be the parts of that could be totally radically shifted if we did want to get this done at a much higher speed?
Yeah, it's very interesting that you mentioned the COVID and the vaccine efforts. So Frontier Climate, which is the new initiative that Stripe launched with several of their partners, which is $1 billion fund or close to $1 billion fund, that will be like basically the first customer of many of these CDR providers. Basically, they model that on a vaccine program. So they call that an advanced market commitment. And the idea is like you bring together a pocket of money where you say, if you can build it and if you build it on time, we are going to be your first customer. We just need to work, and we're going to basically commit this pocket of money in advance. So, and that really accelerated the development of vaccines in the past. And the idea is to apply the same logic to this new class of solutions, which are not yet mature. So the main difference with something like, say, for instance, a power purchase agreement is in a power purchase agreement, you commit money in advance to deploy solutions which are already mature, like wind power or solar power. With an advanced market commitment, what you're doing is you commit money in advance for solutions that should exist, that are not mature yet. But if you can meet the right targets, if you can show that it can work, we're going to be your first customer to help de-risk the solution and down cost it much faster. So I think we need more of that. We need more of that on CDR. We need more of that on many other hard to decarbonize sectors and the related technologies.
Okay. All right. Well, let's come back now into Marble and the program, the approach that you're taking that not just enables some technology to come to life, but also to scale faster and go through these various stages that we talked about. So give us that kind of, we've already heard a little bit about the organization of the business, but what's the program that you offer? And yeah, and then maybe we could have a look at, and then what in return do we need from industrials? What's this kind of the quid pro quo that we need?
Absolutely, absolutely. So the way the program works is that so internally with our team, we pre-identify specific, we call them impact areas, so areas and sectors and problem space where we think there can be one or more interesting companies to build that will really move the needle on how to abate emissions or on negative emissions. So that could be, for instance, different approach to direct air capture, to carbon mineralization, to bioproduction of important key chemical feedstock. And then we look for, we also open like to new areas if people have new ideas to suggest. And then we look for, so we call them founders in residence. So that would be highly technical individuals who typically have finished PhD, postdoc, or have several years of experience in industry, who have like deep technical expertise related to that problem. We onboard them during a program which is about 9 months, during which in the first 3 months phase, that's called the explore phase, we take a step back, we look at the problem, and we try to evaluate and ideate on different approaches, technologies, ideas that can help to crack that problem by talking to lots of experts, reviewing the state of scientific literature, talking to industrials, to scientists, and so on. And then when we land on the most interesting high leverage approach, then we start to actually build a company, to put together the rest of the co-founding team, advisory board, to work on the roadmap, customer development, everything. And then at the end of the process, we spin out the project into a new company, in which we become the first investor, and we invest 250,000 euro into the companies we create that way. So that's how it works.
That was high speed, but to the point. Excellent, well done. And then from the industrials, again, let's come back to the industrials in this. What part do they need to play in this? Do you need them to play in this?
Absolutely. So I think there's a lot of ways they can get involved. I think especially for like decarbonizing hard to abate emissions, I think what's really important is to get the operational insights, like the practical operational industry insights from these executives and these companies. So to take a few examples to make it like very, very practical, if you're developing a process or a technology that will produce low carbon fuels for, let's say, aviation or maritime transport or heavy transportation, you want to get a better sense of, okay, how do these industries and these companies, how do they refuel the vehicle? What are some of the cost targets they have internally for how it will work economically for them? What are some of the safety considerations? What's the supply chain look like today for the fuel they are getting, and how is the supply chain structure going to evolve in the future? What are the minimum volume they're going to purchase the fuel for? Could they benefit for a system that's highly modular and distributed versus something that's centralized? So you have a lot of like operational practical feedback like that you can take as an input, and that will help you to design what should the optimal solution look like. So that's really why we want to speak to this type of companies. Obviously, these large industrial companies have also like R&D departments and scientific and technical expertise. And sometimes they've been working on like certain components, certain parts of the solution that maybe could be integrated into something even more efficient. They could also be you could call them like, venture customers and venture clients, basically the first customers of these solutions. And that leans a bit into the advanced market commitment idea I mentioned earlier. They could do corporate venture capital, and that's something some of them do. I think something that would be very interesting to see would be to see large companies getting more involved with project finance for building the first of a kind and end of a kind plants of these clean tech and climate tech companies, because I think a lot of these large industrial companies, they have the expertise and the know-how of how you build a new industrial site, a new factory, how you put together the capital to build something like that, how do you manage the financing. And I think even though there's more and more venture capital for climate tech and clean tech these days, I think project finance to finance the actual capex, the actual unit, the actual factory, it's a bit more scarce. And I think large industrials could really find, I think, new clever ways to get involved with that part of the journey, I think. And the last thing I would like to say is that I think some of these companies might have great talent, potential entrepreneurial talent, that maybe is thinking about leaving the company, but to build something in the same sector. So I think if they could try to have some kind of a program or something that makes easier to connect these high potential individuals that want to leave the company, but match them with climate tech startups or projects that are not yet created, including the ones we're working on. I think that could be a good way for them to basically establish a relationship also with this new wave of innovator through their alumni. So that would be something very interesting to see as well.
Okay, and before we wrap up on the conversation, I want to come back to your projects and the founders you're already working with. This is your, you've got the floor here, you've got the microphone. So what would you like to explain or kind of showcase about what's happening right now?
Yeah, so at the moment we're working on so we have 4 projects in our pipeline. One is a direct air capture design from first principles to be the most energy efficient possible. So we're working hard on this one. We have 2 projects developing clean molecules for the chemicals and fuel sector, so methanol and ammonia, from two different processes. And we have one which is the desert farming project, where basically we want to terraform arable land in coastal arid regions. We're also thinking that it could create new crops, but also potentially sequester carbon in clever ways, not only in the soil, but also in other ways. And then we are looking actively for people to join us to come, first of all, to become the co-founders, CEOs, and CTOs of some of these companies, but also we're looking for people to join us and build companies in carbon mineralization, bioproduction, ocean carbon removal, and many more sectors as well.
Okay, so plenty of opportunities for people who want to get in that kind of early stage of tech development. And what, again, we'll end with a kind of reflection on what's the call to action, therefore, for domain experts, investors, or the industrials. You know, who would you most like to hear from, and what could be useful to Marble and the cohort that you have at the moment?
So I think for people listening to this podcast and who are interested in founding a climate tech company and are wondering whether it's the right time, I think there's never been a better time to launch a climate tech company. First of all, because we're in the middle of a climate emergency and we need all hands on deck to build this new wave of solutions. I think there's never been that much funding available for talented, ambitious entrepreneurs to work on this type of problem. There's a lot of talent wanted to join you on this journey and to build a great team on this. And there's a lot of super interesting and fundamental problems to work on. So I think it's really fantastic. Probably the bottleneck, and that's what we try to focus on, is finding people who are exceptional potential founders, meaning who have this unique combination of like technical insights, domain insights, and high founder commercial potential. And then it's matching these individuals with the right problem statements, with the right problems to work on. And so that's basically the core of what we try to focus on. But then for people listening who are maybe not thinking about launching their company, but they're working in large industrial companies, I think there are different ways they could get in touch. First of all, if maybe they have a colleague who could be like a great founder or potential CEO for one of our companies, please get in touch. If they are an experienced executive or operator in one of these industrial firms and they're looking for advisory opportunities to advise young climate tech companies to provide the industry insights, please get in touch. Or if you're facing like some hard climate problems in your industries and you want to get in touch with us to tell you about the kind of problems you want to solve to reach net zero and you're looking for new solutions, we'd love to hear about it, and maybe we can develop something that would help to solve it.
Brilliant. All right, well, Ben, thanks so much. I'm glad that we persisted with our mutual diary nightmares to have this conversation. I really appreciate you coming on, so thank you very much.
Thank you so much, Alex. It was fantastic.
Many thanks for listening to the Decarb Connect podcast. We work with clients across the industrial sectors, specifically those who are tasked with decarbonising the most energy-intensive products and materials that we use every day. If you have an interest in learning more about either our members network, our reports, or our event series, do get in touch with us at decarbconnect.com. Or if you'd like to take part in the podcast, email me, Alex, at ac@decarbconnect.com. Thanks for listening.